Hello, Math 005. What we're looking at today is 5.2, negative exponents and scientific notation. So the first thing we're going to talk about is negative integers as exponents. So we're going to consider a to the negative fifth. The rule is that when we have these negative exponents, we're going to keep in mind that they're always going to be, if we don't see a denominator in the numerator, like so. When we work with negative exponents, the idea is to always make those exponents positive. We never, ever, ever want to answer with negative exponents. The way we make those exponents positive is by moving whatever the base in that negative exponent is to the other side of the fraction bar. So if we were using this, we would say this is equal to 1 over a to the positive fifth power. Again, when you move it to the other side of the fraction bar, the exponent changes its size or sign, sorry. With that, if you have, we'll say 1 over a to the negative fifth power, now you'll see it's in the denominator. So how do we make that exponent positive? You would have to move it to the numerator, and it would be a to the fifth. So again, you always move it to the other side of the fraction bar in order to make the exponent positive. This only applies to exponents, not the coefficients. So looking through the first set of examples here, express use of positive exponents and if possible simplify. 4 to the negative 2 power. Again, we want to think of this over 1. But we want to make that exponent positive, so we need to take this and move it to the denominator, which would be 1 over, and now it would be 4 squared. Now 4 squared is something we can easily evaluate, so it'd be 1 over 16, and we'd leave it just like that. Now a way you can check this is type in your calculator 4 raised to the negative 2 power, and you're going to get 0.0625. Then if you type in your calculator 1 divided by 16 or 1/16, you get the same decimal form. Okay, what I want you to do now that we just worked through that one example, I want you to pause the video and try out B and C. Okay, looking at letter B, we have negative 3 to the negative 2 power. We need to move it to the denominator, which would be 1 over negative 3 to the second power. Keep in mind, this negative 3 is the base and it's in parentheses, so it's negative 3 times a negative 3, which is positive 9. Again, you can type this into your calculator just as you see it with the parentheses and type 1/9 and you'll get the same decimal form. We never want to answer these as a decimal. You always want to represent them as fractions like I did here. Do not just type these into your calculator and hit enter and give me the decimal. You will not get it correct for that. Letter C, I wrote be careful here because you need to be very careful with what is the base of the negative exponent. You'll see since there is not parentheses around the AB, that negative 1 exponent only belongs to the B. So the A stays where it's at and we only move the B to the denominator. And we don't need to write the exponent of positive 1, so it's just A over B. Okay, the next one, we're going to continue to simplify these. Now, there's more than one way that you can do these, so if your initial thought isn't what I did, that might be okay. So for letter A, we have t to the fifth times t to the negative 2. We could set this up very similar how we just did the previous ones and move the t to the negative 2 into a denominator and so forth, but we'd still have to simplify those t's. We can also keep in mind that when you have the same base being multiplied, you can add those exponents. So we can do 5 plus a negative 2, which is t cubed. Next one, we have b. This one is going to use the product rule. This is where we have to multiply that exponent by all the exponents inside. Keep in mind the exponent of 5 is going to be a 1. So we have to take that negative 4 and multiply it by all the exponents here. So we'd have 5 to the negative 4th power. This would be x. Negative 2 times negative 4 is positive 8. And then y to the negative 12. Now from here, we can put all of that over 1. And now we can see what needs to go to the denominator. The 5 to the negative 4th and the y to the negative 12th both need to be moved to the denominator to make those exponents positive. The x to the 8th stays in the numerator. Now that would become 5 to the positive 4th power, but when we evaluate that, we'd get 625. So this would be 625 y to the 12th. Go ahead and try letter C, and I want you to at least give letter D a try. And if you get stuck on it, that's okay, but at least give them a shot and then start the video up and see how you did. Okay, Letter C. Again, you could have approached this in two different ways. One, since you see these both have negative exponents, you could have interchanged them with the numerator and denominator. Since they're set up as a quotient, I subtracted them. So I did x to the negative 4 minus the negative fifth power. Again, when they're set up as a quotient, you subtract the exponent. So negative 4 minus a negative 5 minus a negative becomes addition. So negative 4 plus 5 is x to the first power. Again, you always do that in the numerator, so it's over 1, which simplifies to just x. Letter D. First thing I did is I separated it into the different things. So I have my coefficients, my base of x's, and my base of y's. Negative 10 over 5, that simplifies to a negative 2. Again, it's okay to have a negative coefficient. And then we subtract the exponents. X to the negative 3 minus 2 over 1, and y to the 1 minus 5 over 1. Negative 3 minus 2 is a negative 5. 1 minus 5 is a negative 4. Then I have to take both of those with the negative exponents and move it to a denominator, and I was running out of space, but you see an answer of negative 2 over x to the fifth, y to the fourth. Okay, next page. We're going to continue simplifying these. So we have here is simplify s over t to the, let's see, we have the negative fifth power here. So what we want to do is there's a couple ways you could work through this problem. One of the ways we could do this is we could distribute that negative 5 to each of those exponents like we did in the previous sections when we had a quotient like this. So s to the negative fifth over t to the negative fifth. Now since these both have negative exponents, we'd want to send the numerator to the denominator and the denominator to the numerator. So here we'd have t to the fifth power over s to the fifth power. Then what we could even do with that is now that they have the same exponent, we can even say t over s to the fifth power. So that brings up another thing we want to keep in mind. When you look at the two initial parts of this problem, so looking at the initial start and where we ended up, these two things here, this is going to be an important rule that you can use with other problems. That these two, if you look at the base themselves, the base is the reciprocal, but then the exponents are opposite. So if you flip everything within the base, you can change the sign of your exponent, and that makes it a positive. So looking at that idea in this next one, simplify x to the negative fourth over 2y to the negative third power. I can make this a positive 3 by just flipping everything in the inside. So 2y over x to the negative fourth. As long as you flip everything as it is, exactly how you see it, you can change that outside exponent sign. Now we can go ahead and simplify. And we need to simplify because we still see that negative exponent. So with this, we could, remember, we'd have to distribute that 3 to every exponent inside of this. So we'd have 2 cubed, y cubed, and x to the negative 12th. We have to continue to simplify. Since this x to the negative 12th is negative, we want to move that to the numerator. And we also have 2 cubed, which we know is 8. So we have 8x to the 12th, y cubed, and that would be the simplified version. Another way you could have done this is you could have taken this negative 3 and distributed it right from the beginning and then continued to simplify. Either way works fine. What I want you to do now is pause the video and try out these 3 problems here. And then restart it and see how you did. Okay, problem A, we get 81 over x to the fourth. Problem B, we get 5b to the fourth over a to the seventh. And then this last one here, you can follow my work, pause it if you need to, but in the end you get 1 over m to the fifth times n. Again, if you have any specific questions on these, please email me and reach out with where your question lies, and I can hope clarify it for you a little bit better. The next idea we're talking about is scientific notation. Scientific notation is used to express numbers that are either very, very large or very, very tiny, meaning a lot of digits in them. And then the form that we're going to use here is n times 10 to the mth power. Now there's certain things you need to know about this. M has to be an integer. meaning it can be a negative or positive number. All the exponents we've looked at so far are all integers, -3, -2, 4, -7, and so forth. So a negative or positive value. And then n, what we have to know about n is n has to be bigger than or at least 1, but less than 10. So we say it has to be at least 1, but less than 10. So it can be 1.0 all the way up to 9.9999 and continuing. It has to be between 1 and 10, okay? You always need a number to the left and to the right of the decimal. The left needs to be at least a 1 and no bigger than a 9, only one digit there. That's going to be the form we need to use for scientific notation. Anytime you have to answer in scientific notation, it must be in that form. N, at least 1 less than 10. M has to be an integer. When m is positive, it takes a decimal and it moves it to the right m amount of places. When m is negative, it moves the decimal to the left. So let's go ahead and look at some examples here. So for the first two, we're converting to decimal notation from scientific. So first thing we do is look at the exponent. Here you see that it's a positive exponent. That means we are taking the decimal right here and moving it 5 places to the right. So I'm going to actually rewrite this number. Let's say 7.893. And we're taking it, moving 5 places to the right. So 1, 2, 3, 4, 5. And that's where our new decimal is going to lie, which means we need to add a couple zeros in there to complete it. So it'd be 789,300. If you want, you can put a comma in there. This would be the decimal notation. Now we don't write the decimal out here, but it would be right here if you wanted to add it and put a 0 after it, but you don't have to in this case. So again, if this exponent is a positive number, that tells you this should be a large value number, and you move it to the right because positive numbers go to the right. Now this next one, we have a negative number here. When the exponent is negative, that tells us that this number in the end should be a very small value number. So we're going from 4.7 and we need to move it 8 places to the left. 1, 2, 3, 4, 5, 6, 7, 8. And that would be our decimal. We have 1, 2, 3, 4, 5, 6, 7 zeros that we need to fill in here. So point 1, 2, 3, 4, 5, 6, 7, and then that 4, 7. And then you always want to make sure you have a number on the other side of your decimal, which is in this case going to be a 0, so you just fill it in. This would be decimal notation. Again, if this is a negative exponent, it tells you your value is going to be very small, between 0 and 1. If this is a positive number, you know this is going to be bigger than 10. So positive, big number, negative, small number. Now we're going the other way with this. So the first thing we have to do is look at the non-zero digits, 8 and 3. Remember, we need to put a decimal someplace in there to put that number between 1 and 10, which would be 8.3. And then it's going to be times 10. And now we need to think of which exponent we need to fill in there. So you go back to your number and look at it. You ask yourself, is this a big number or is it a small number like this? And we say, okay, it's a big number, above 10. That means your exponent's going to be positive. So you think, okay, how many places is it from 8.3 right in here to the end? And you'd say it's 1, 2, 3, 4. Well, we already said it has to be a positive value here. So we know that we need to fill in the box here with a positive 4. Make sure you check your work. Think, okay, positive 4, move it to the right 4 places. Do I get that? Yes. Okay, I want you to pause the video and try the next one. Okay, we see here that 3, 2, 7 are our non-zeros. The only place to put the decimal to make it between 1 and 10 is 3.27. Again, it can't be 32.7 because that's bigger than 10, and it can't be 0.327 because that'd be smaller than 1. So 3.27, and you say, okay, that's 2 places, and since it's a small number, a negative exponent, so 10 to the negative 2 power. Remember that positive exponents are used to represent large numbers and negative exponents are represent small numbers between 0 and 1, which is what we've said. So now what we're going to be doing is using our calculator to work through these. So consider this example right here. You can look at that. When two or more measurements written in scientific notation are multiplied or divided, the result should be rounded so as the same number of, and we're going to call these significant digits as the measurement with the few. So significant digits are going to be our non-zero numbers. 3.1 has two significant digits, 2.45 has three significant digits. And what you want to do is answer with the smallest amount. So since the smaller one has two, you would have two values when you are rounding those. So just keep that in mind, and we'll discuss that as we work through these answers here. So what you're going to be doing is using your calculator to do this. So example A says, use your calculator to simplify each expression. Write scientific notation for the answer. So what I want you to do, I'm actually going to let you try these out on your own. I want you to start with A and B. Type them into your calculator just as you see those and press enter and record what your answer should be. Now you'll see an E on your calculator that represents the times 10. So go ahead and give these a chance or give them a shot, try them out, and then unpause your video to see how you did. If you feel confident, try letter C out as well. Okay, you can see here, I just took a picture from my calculator here. You can see that I typed this first one just as you see it here. I used parentheses. Make sure after you type the 5, you have to hit the arrow button to the right so you get the big parenthesis. That way you don't type everything up in the exponent. And then we get our answer there. And then I do the same thing. Again, I used the fraction template here. That makes it a lot easier so we don't type things incorrectly. You want to be very careful with that because if you don't use a fraction template or parentheses, things might not come out correct. And then what we'd want to do is make sure we write these in the correct scientific notation. So for this first one, we see that each of these have 2 sig digs. So we need to round this to have 2 sig digs in its answer. So this would be 3 point, and since that's a 0 and that's a 9, the 9 would round the 0 up to a 1. So that would be, for letter A, your answer would be 3.1 times 10 to the 15th power. Letter B, you can see that we have 3 sig digs and 3 sig digs, so that means our answer will have 3 sig digs, which would be 7.5. Then you have to add a 0 there, so it's 3 and 3. And this would be times 10 to the negative 14th. And that would be the answers you'd want to use for those. Now, letter C. Two different pieces of metal have thicknesses of 13 over 1280 and 11 over 1280. Find the sum of their thicknesses. Write your answer in scientific notation, round to 2 significant digits. So a couple things, it tells us to find the sum, which means we need to add these two things together. So 13 over 1280 plus 11 over 1280. Use your calculator for this, or you could do it by hand. They have a common denominator, so you could just add them up. So 13 plus 11 would be 24 over 1280. Now use your calculator to divide that if you need to. So we'd have 24 divided by 1280. When you do that, you're getting 0.01875. Now we have to change that to scientific notation. So think back to the top here. We need to put our decimal right there. So this would be 1.875 times 10, and that's a small number, so it's a negative exponent, and that would be 2 places, so to the negative 2 power. However, we want to round to 2 significant digits, so we'd only want to have 2 there, which would change this to 1.9 times 10 to the negative 2 power. And again, you could do all of this on your calculator. You could use the fraction template and type 13 over 1280 and do plus, and then again the fraction template of 11 over 1280 and find that you would get 3 over 160 is what your calculator says, and which is the same thing that we found. We just did not reduce it from here, which is okay because we're going to decimal anyway. That's all we have for 5.2, so please reach out if you have any questions on anything, and good luck on your homework.